much work is done? Well, we've got a graph here, and in our graph we've got pressure versus volume, and we've got an arrow telling us that this graph is going in this direction, so the volume is increasing over time. Okay? We learned recently that the work that is done is equal to the area under the curve of a pressure versus volume graph. So we simply need to find the area here. Well, what is the area underneath the curve? Well, we drop this down. We've got a trapezoid here. And if you recall the formula for a trapezoid from geometry, great. Go ahead and use it. If not, you can break it into a triangle and a rectangular piece, and then simply add the two together. Okay? So, let's go ahead and look at the triangular piece first. So the area of this triangle is going to be equal to 1/2 the base times the height. Well, in this picture, the base is from 3 to 7, or 4 meters cubed. And the height of the triangle, so this is the same base as down here, but the height's a little bit different. The height starts at 101,300 and ends at 145,000. So this height is going to be 145,000 minus 101,300. Okay, so the height of this is going to actually be 43,700 pascals. Solve this and we find the area of the triangle is 87,400. But that's only part of the area underneath the curve. We also need to find the area of the rectangular portion. Well, the area of a rectangle is the length times the width. So in this case, the length 4 meters, 4 cubic meters, and the width starts at 0, goes to 101,300, so 101,300. So the area of the rectangular part is going to be equal to 405,200. If we want to know the total amount of work that was done, we need to add these two together. So the work total is going to be equal to 87,400 plus 405,200, which gets us a total amount of work of 492,600 joules. Okay, now one thing to keep in mind is that this process was going to the right. The volume was increasing. Therefore, this is a positive number. Okay, a positive amount of work was done. Let's look at another one. Okay, similar. Same thing happens in the beginning. First, we're going to start here. Volume increases. Okay, then in the second portion, the volume stays constant. And in the third portion, the volume decreases. So we're going to have 3 portions here. Okay, I'm going to label the corners of this triangle A, B, and C. Okay, so we want to know the total amount of work that was done, or the net amount of work. So again, work is equal to the area under the curve. So the first thing we can do is find the amount of work that was done from A to B. And if we go back and look, we just found that. I kept all the same numbers. So this is the amount of work done from A to B. Okay, so we still have that 492,600 joules of work done from A to B. The work done from B to C, well, there is no area under the curve here. And that's because this is isochoric, volumetric, which means that the volume's not changing. And if the volume's not changing, there's no area under the curve, and there is no work done. The last part we need to do is the amount of work done from C to A. Well, from C to A, we need to find the area under the curve. Well, it's a rectangle. Okay, so it is length times width. So the work done from C to A is the length. So from 3 to 7, which is 4. But again, we're starting at 7 and going backwards. And we always do the final minus the initial. So it's -4. And then the width, again, is going to be 101,300 pascals. So the work done from C to A is going to be -405,200 joules. And it's negative because the volume is decreasing. Okay? Now, if we want to know the total amount of work that was done during this process, so the net amount of work, we simply are going to add these up. So we have 492,600 plus 0 plus -405,200, which gives us a total amount of work done of 87,400 joules. Notice that even though we had a positive portion, a zero portion, a negative portion, in this case we turned out with a positive amount of work that was done. Okay, if you have a process that's kind of cyclic and it's clockwise, you're going to get a positive amount of work done. If it would have happened to be counterclockwise, we would have gotten a negative amount of work done. So okay, so if it goes clockwise, we're going to have a positive amount of work done, and similarly, if it goes counterclockwise, a negative amount of work done.